Hello everyone, welcome to Dr. Ravi's Academy. In today's class, we will be learning a topic on analysis of frames. To be specific, a frame with three members. How to analyze a problem with the method of joints we will be learning. So this particular topic is a very important topic, and of course it is useful for BTech first year mechanical as well as civil engineering students, and even it is useful for gate examination also. Now, in this particular problem, let us understand very clearly the procedure, that is what is the method of joints. Let us look at the problem. Truss ABC shown in figure has a span of, the length is given 5 meters. It is carrying a load of 10 kilonewtons at apex. Find the forces in the members. So he's asking the internal forces in the members when it is loaded externally. So this is the problem, and these problems you are going to solve in two stages. In first stage, you will be finding out the support reactions RB and RC by considering equilibrium of a total truss, and then second stage you will be considering the free body diagram of each individual joint, and you will be determining the internal forces in the members. So let me write step 1. So you are going to draw the free body diagram of truss, the total truss you are going to draw, and your intention is you want to find out the support reactions by considering these free body diagrams. Support reactions, here it is RB and RC. Let me write down very clearly, it is RB and RC. And step 2 is you are going to draw the free body diagram FBD of a joint, and you can select the number of joints as per your requirement, the free body diagram of joints, and you will be finding out internal forces in the members, internal forces in the members. So these are the two steps you are following for a simply supported truss, and in this let us consider the equations of equilibrium, that is sigma m moment sum about B is equals to 0. Let us write down this equation. Considering clockwise turning moments are positive and anti-clockwise is negative. Here, this particular force 10 kilonewtons is, this is the line of action of the force, and this is the moment arm. So you have to find out this particular distance. So that you can find out simply in this right angle triangle. The projection of 5 meters on this is 5 cos 60. So this length is 5 cos 60, and consider this right angle triangle, and the projection of this hypotenuse on this is d becomes 5 cos square 60. That is the momentum for the 10 kilonewtons. So it is contributing clockwise, and 10 into it is 5 cos square 60 is the momentum, and it is RC. So when you are drawing the free body diagram, let us remove the supports. I am removing the support and incorporate the support reactions. Here it is, I am writing it as RC, and this is RB. Because there is no horizontal force, even though it's a pin connection, hinge connection, you have only vertical reaction. And here RC is contributing anti-clockwise, that is minus RC into momentum is 5 meters is equals to 0. So, and from this we can find out RC is equals to, it is 10 into 5 cos square 60 divided by 5. So this 5 goes off, and it is 10 into cos square 60 is 1 by 4, and you are going to get it is 2.5 kilonewtons. The force is RC is 2.5 kilonewtons, and write down sigma Fy is equals to 0. Sum of the forces along the vertical direction, that gives you that RB plus RC is equals to 10 kilonewtons, and RC is known. From this, RB is equals to, it is a 10 minus 2.5, it gives you 7.5 kilonewtons. So you got RB as well as RC. RC is 2.5, this is 2.5, and this is 7.5 kilonewtons. So this is the first step. in a simply supported truss. Draw the free body diagram of the total truss. That means you have removed the supports and you have incorporated the reactive forces and apply equations of equilibrium. You have three equations of equilibrium: a moment equation and the force along the y direction as well as force along the x direction. There is no component of the force along the x direction, so that equation is no use of it. It is, you can simply got this RA and RC, RB and RC. After knowing this, let us draw the free body diagram of a joint. Let us select a joint B. So I am writing it as a free body diagram of joint B and analyze this. So you have to select the joint in such a way that it's very important that you have to look at that there must be only two unknowns whenever you selecting a joint for the free body diagram for the analysis or to determine the internal forces. You have to see that you have only two unknowns. So then only now let us see free body diagram of joint B will be, this is the unknown, this is the unknown. Only two unknowns you have. So I have selected B as the free body diagram for my analysis, and let us draw the joint. This is joint B, and you have RB, the support reaction. It is 7.5, and let us assume that in this tensile force in member BC, you are assuming it is representing a force away from the joint is tensile. I am writing it as BC. So the internal force in the member BC is represented away from the joint, and it indicates it's a tensile force. And I am assuming in AB at an angle 60 degrees. This is 60, and this is a force in AB. I'm assuming it is toward the joint, means it's compressive. It's only an assumption. Unknowns you can assume in any way. Either you can assume it as tensile or compressive. Does not make any difference. Now let us apply equations of equilibrium. So I am writing it as sigma Fy is equals to 0. So don't apply Lami's theorem to solve these unknowns, because the forces or the internal force are sign sensitive. It is away from the joint is tensile and toward the joint is compressive. The moment you apply Lami's theorem, always whenever you have three forces, you must represent away from the point of concurrency, and the nature of the force is going to change. So let us use equations of equilibrium preferably. So sigma Fy is equal to 0. Here you can see that 7.5 it is positive, and minus FAB it is sine 60 is equals to 0, and FAB is equals to, it is 7.5 divided by sine 60, and this gives you the force in the member AB, that is, it is 8.66 you are going to get kilonewtons, and the nature of the force you got positive, as you have taken it as AB as compressive, so it is compressive. FAB you got it is negative, it is toward the joint you got positive sign. So positive sign indicates means it is the direction of what you have assumed it is compressive is correct direction. So let us conclude this is one force, and let us write down sigma Fx is equals to 0, some of the forces along this, and this gives you, you have FBC which is positive, and the component minus FAB, it is cos 60 is equals to 0, and this equation FBC is equals to, it is FAB 8.66, cos 60 is 1 by 2, and you are going to get 4.33 kilonewtons, and it is, you got positive sign, means that FBC you have taken it as tensile, and it is a tensile, you got it is tensile. This is the free body diagram of the first joint, and these two forces you have calculated, and only left over is this. For that, let us draw the free body diagram of joint C. So let us represent the joint, and you have RC acting vertically upwards, it is 2.5. And this force, you have concluded that BC, you have BC nature of the force is tensile. You must follow the tensile only. You cannot represent as compressive. So this is FBC. So whatever known forces are there, you must follow as it is. Unknowns you can take any way. You can assume any nature, tensile or compressive. Let me assume that it is tensile. The force in member, it is AC. Force in member AC. Angle is 30 degrees. So let us write down sigma Fy is equals to 0. Sigma Fy is equal to 0. Sum of the forces. This force, it is vertically upwards. It is FAC. It is sine 30. FAC sine 30 plus 2.5 is equals to 0. 2.5 is equals to 0. There is no component of the force because it's horizontal. So now you have FAC is equals to minus 2.5 divided by sine 30. So sine 30 value, it's 1 by 2 and this becomes minus 5. And see that it is minus, you got FAC, and in free body diagram you have assumed that it is a tensile. So you can conclude that it is not tensile, it is compressive. So FAC is equals to 5 kilonewtons and it is compressive. So this is what is the method of analysis, and of course this force is already known. I hope you understood the methodology how to analyze a simply supported truss by means of a method of joints. Thank you very much for watching this video.